And so what makes one substance get a higher temperature faster than another is the makeup at the molecular level. It's how the heat energy, like if you had a glob of heat energy, the heat that goes from one substance to another, as it leaves one substance, it slows down, that substance slows down and its temperature lowers. And as the heat goes into the next substance, it increases its molecular energy and its temperature rises. So this heat energy, if we can think about it as balls of heat energy, some substances require more heat energy to increase their temperature to the same temperature as another substance. So, say we wanted to raise something to 75 degrees Fahrenheit or Celsius, we wanted its average molecular speed to be something that was related to 75 degrees Fahrenheit. If we wanted to do that, then we would need X amount of energy depending on the material. So, for example, water and the ground. If we wanted to raise water to 75 degrees Fahrenheit, we would have to have a lot more heat, a lot more of those bubbles of energy, heat energy, to raise it to 75 degrees Celsius than if we wanted to raise the ground or rock, like rocky material, to 75 degrees Fahrenheit, because the specific heat of the material. The specific heat of the material is that property of the material that says how much heat energy it takes to raise the temperature of that material. And water has a much higher specific heat, requires a lot more energy to raise it a degree to 75 degrees Fahrenheit or wherever you're trying to raise the temperature to than it does for rock. So this is the reason why if you have a pool or if you've been to pools before, the concrete around the water gets hotter, much quicker than the water itself because the specific heat of the ground is much lower. It doesn't take nearly as much heat energy to raise the temperature of that ground, and so the ground gets to a much higher temperature than the liquid, the water, because the water requires a lot more heat energy. Still get both of those materials are getting hit with basically the same heat energy, but the structure of the water at the molecular level changes it into speed and goes faster at a different rate than the ground, and that's what we call specific heat, the rate at which that heat energy is transferred into temperature.